right, we're going to pick up where we left off on 5-3. Okay, so the first thing it says to identify each equation as out of a line, parabola, circle, or absolute value. So let's look at our first one. Is that a line, circle, parabola, or absolute value? It's a parabola because there's just one squared term. Okay, y is not also squared, so okay. So you can add 4. So it's y equals. Okay. So parabolas, let's talk about the transformations from the parent function. So that negative out front means that you reflect over x, and then the plus 4. You go up 4. So if you think about your parent function of a parabola, so you're at 0, 0, and then 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. That's the parent function because you're squaring your values. Okay, so then reflect over x and shift up 4. So this is on x, so reflect stays where you are. Shift up 4. So I'm starting here with my vertex. 1, 2, 3, 4. Okay, then let's do the other points. So if I do this one right here next, reflect over x and then shift up 4. Okay, and then we'll continue that. Some of you might know just like the squared pattern, and you know that it opens down, so you could do it that way too. Okay. I just want to erase those points now. So I'm looking here. Okay. So that one's done. Let's look at our second one. And is this a line, parabola, circle, or absolute value? Absolute value. So let's talk about the transformations here. So the negative out front, again, means you reflect over x. The minus 1 inside means you shift. Okay, good, right 1, and then the plus 3 is up 3. So that's also where my vertex will be. So like for the parabola, my vertex would be at 0, 4. So let's just try to do this without having to graph the parent function first. So 1, 3, the vertex. It reflected over x, so is it opening up or down? Down, because it reflected over x. All right, absolute value is a v. So the slope is just 1, unless there's a stretch or shrink, unless there's a number out front. So I'm going down, but the slope is 1, so down 1, right 1, down 1, left 1, and so forth. Okay? Okay. All right, so we're looking for the solution to this system. So the solution to the system is where they would intersect. I see how many solutions? 2. Right here and right here. So that's 1, 3, and negative 2, 0. Okay? Now, plug those back in to check and make sure that it's correct. Okay, that looks like my 2 solutions. Alright, I'm going to show you how you can find this on the graphing calculator. So feel free to grab one and follow along, or you could just watch. It won't be a requirement to do it on the test, but it'll help you check. Okay? Okay. So go to y equals, and then we want to type these in. And you have to do the one where that's solved for y. So the negative x, so x, remember, is next to alpha squared plus 4. So the one where we already added the 4 over. Okay, and then absolute value, so negative, and then absolute value is under math, and then over to number, it's the first one. So math, number. So, and then that was x minus 1. Make sure to close the parentheses so you close that absolute value. Okay, and then plus 3. All right, when I graph these, I want to say normal 10 by 10 window. So if you hit zoom 6 for the standard graph. Okay, so first of all, it actually looks similar to the one you graphed. Okay. All right, now I want to know where they intersect. And you can probably tell by looking at this graph, but it can give me an exact answer as well. So anytime you want the calculator to help you find something on your graph, you most likely will go to the calculate. So that's second trace. Second trace. And we want where they intersect. So go down to number 5. Number 5. All right, so these 2 questions are just going to make sure they're looking at the right graphs. And this is really only if you have more than 2 graphs on there. You would have to tell them which 2 you want to look at. But since we just have 2, you can kind of just hit enter through those. All right, now for the guess, you want to get kind of close to them because there's 2 different ones. So you kind of got to tell where to look at each time. So I'll do this first one, the negative 2 one first. So let me just kind of scroll that way. And for guess, I'll hit enter. Okay, negative 2, 0. And then you do the same thing for the other one. So go back to second trace, number 5. Hit enter for first curve, enter for second curve, and then go by, scroll over for your guess towards that other point. And that gave you the other one, 1, 3. Okay, so this can be helpful even if you're not graphing, having to actually graph by hand. You could still maybe find where they intersect like this. Just to check, you'll have to show all your work on your test, but this can help you check. You also, you can check by plugging them back in. Okay? Okay, so let's get back to solving algebraically. just says solve the system. It doesn't tell us a way. I don't want to do elimination here. I mean, you could because your y's are lined up and could eliminate, but it kind of makes this side a little bit of a mess. So I think I'll do substitution. And I'm going to solve the first equation for what variable should I solve for? Yeah, for the y, because you're not going to be able to square root and get anywhere. So remember, you can't really, when you're doing substitution elimination, you can't remove an exponent or put an exponent on. Okay, so the exponents aren't going to change. So that will be y equals negative x squared plus 6x. Okay, so I'm going to take this and I'm going to substitute it in for which variable? Good, for y in the second equation here. There's nothing in front of y, so I don't have to worry about parentheses. Okay, I see that I have a quadratic, so I want one side equal to 0. Before I do that, I need to multiply out this x minus 3 squared. Okay, so let's do the shortcut. So that's your a, that's your b. So a squared, so x squared. And then 2ab. So x times negative 3 is negative 3x times 2 is negative 6x. And then b squared, so negative 3 squared is positive 9. Okay. So then on the left, I just have negative x squared plus 6x minus 11. All right, I'm going to move all the terms from the left to the right because I want a positive a value. I want a positive x squared. So I'm going to do this one step at a time just so we don't get mixed up. So let's see. I'm going to add x squared. So 6x minus 11 equals 2x squared minus 6x plus 9. Okay. Now I'm going to subtract 6x. Negative 6x minus 6x is negative 12x. And then finally, add 11. Okay. So usually when I have a quadratic, I want to try to factor. What can I do to make this factoring easier? Good. Factor out of 2. So what happens then to that 2? Yeah, it's just going to cancel. It's going to divide out because 0 divided by 2 is still 0. And so really that 2 just goes away. Okay, so now let's think. Well, it multiplies to give me 10 and adds to give me negative 6. Nothing, right? I only have 2 and 5 and 1 and 10 to use. So if it doesn't factor, I do what? Quadratic formula. So x equals opposite of b plus or minus b squared minus 4ac all over 2a. So what is the opposite of b? b squared is negative 6 squared. What is a? So minus 4 times, what's a? Times what's c? 10. All over 2 times 1. So just calculate what's under the radical first, so the discriminant. Don't do it in 2 steps either. Just do negative 6 squared minus 4 times 1 times 10. All at one time. We get negative 4. So then, how do you square root of negative? It's imaginary, so we have no solution. Let's think about what it is that we're solving, like what type of graphs. The first one is what type? The top equation, if you graphed it, would be what? It's a parabola. It's quadratic because there's one square term. So if you subtracted, it'd be a negative x squared. If you had y by itself, it'd be negative x squared. So that one opens down. Okay, this one is also quadratic. The square would be with the x. And it's a positive x squared, so that one opens up. So your graphs look something like that, and that is why there's no solution. Questions about that? Okay. So we're going to do this system. So we do have just a couple problems that have logs in it. It says solve using the method of your choice. You really can't do elimination too well, so we'll use substitution. So it is y equals already. So I'm going to take this and substitute it in for y. There's no base, so it's base 10. So log base 10 of x plus 4 plus 1. All that goes in for y. And then I have minus 2 equals negative log base 10 of x plus 7. Okay. Let's combine your like terms real quick. So that'll be log base 10 of x plus 4 minus 1 equals negative log base 10 of x plus 7. Okay. So I need to somehow get rid of the log so I could get some for x. I cannot do this yet. I cannot do that yet because I have a minus 1. So that's not going to work. So what I need to do is put the logs on one side. So then I can condense them to just one log. So I'm going to add the 1 to the right, and I'm going to add negative log base 10 of x plus 7 to the left. So I'm going to add the 1, and then I'm adding log base 10 of x plus 7 to the left. Okay, so on the left, I have log base 10 of x plus 4 plus log base 10 of x plus 7 equals, on the right, I just have 1. properties of logs, they're same base. I can condense those by multiplying. So log base 10 of x plus 4 times x plus 7. Okay. You can go ahead and multiply if you want. If you want to go ahead and multiply out. So FOIL x plus 10 and x plus 7. So that's x squared. The outer is 7x. The inner is 4x. That's 11x. And then 4 times 7 is 28. Okay. Now, I don't have logs on both sides to cancel. So what I have to do to get rid of log base 10, to get rid of a log, you do the inverse. So exponentiate both sides using base 10. Okay. So that cancels that log there. So you have x squared plus 11x plus 28 equals 10 to the first, which is just 10. So what would I need to do now? Subtract the 10. Okay. This one does factor. Multiplies to be 18, adds to be 11. Okay, so positive 9 and positive 2. So I have two solutions for x. We need to go back to find the solutions for y. So back substitute. So we'll start with x equals negative 9. So y equals log base 10 of x plus 4 and plus 1. Okay, so that's log, and log base 10 is in your calculator, so that's fine. I get negative 5 plus 1. Okay, well if you try typing that in, you're going to get an error because you can't take log of a negative number. Okay, so then this one had no solution here. Okay. Now let's try x equals negative 2. So that's log base 10 of 2 plus 1. So you could type that in and we'll approximate, let's do 3 decimal places. So I have 1.301. You guys got? Okay. Let's see if I plugged it in to the other one. And you get the same thing. It won't look the same because that one would have been log base 10 of 5, and then plus negative log base 10 of 5 plus 2. But, so their exact answers would not have looked the same, but their values would be the same still. Okay? So make sure you write that as an ordered pair. Okay. Questions about that? I know that was hard. Okay. Alright, so that's definitely the toughest system, besides doing the 3 by 3, the X, Y, and Z. Toughest type of system that we see. Here's the one that's similar. We're going to skip that one because that won't be on your test. But this will, and I want to talk about this. So we're going to talk about nonlinear inequalities now, and we will graph these. Okay, so I'm going to add some notes about inequalities as we go through this. First of all, one note is the solution will be the shaded region, and then when it's a system, it's where the shading overlaps. Okay, so you can shade each one individually, and then the overlapping part is your solution to the system. So if you shade each one, make sure to darken in that region. I'm going to just use arrows until we get to the end, and I will just shade what would be overlapped. And I'll show you as we go through. Okay, so first of all, in general, so a greater than or less than, you use dashed lines. If it's greater than or equal to or less than or equal to, you use solid lines. So what type of graph is this first inequality? Yes, and it'll be, so this is a circle, and will it be a solid or dashed circle? Solid. Good. Okay, so with the circle, you graph the center and radius. So my center, my center, 0, 0. So you don't have H or K, so just 0, 0. And my radius is 5, square root of 25. Okay, so go out 5 in all directions. And draw a solid circle. Okay? Now, shading a circle. Okay? If it's less than or equal to, you shade inside the circle. If it's greater than or equal to, you shade outside the circle. Okay, so would you shade inside or outside this circle? Inside. So I'm not going to actually shade, I'm just going to draw arrows showing me that I would be shading inside that circle. You're welcome to go ahead and do the shading if you want. Okay, so there's my circle. What's my next inequality? What's that graph? Yep, it's a line. So let's get y by itself. So 2y less than or equal to negative x plus 5. Divide everything by 2. So y is less than or equal to negative 1/2 x plus 5 halves. So remember, that's your y-intercept, 5/2, and -1/2 is your slope. Remember with inequalities too, if you divide by a negative, you need to flip your sign. We divided by +2, so we didn't need to worry about that, but sometimes that happens. Okay, so start at 5/2. So start at 2.5. And then my slope is -1/2, so down 1 and right 2. Or up 1 and left 2. Will this line be solid or dashed? Solid. Okay, shading with lines. If it's less than or equal to, you shade below the y-intercept. So the side of the line that's below the y-intercept. If it's greater than or equal to, you shade on the side of the line that's above the y-intercept. I'm going to say here for the circle and parabola as well. Circle and parabola do pretty much the same thing. Okay, so there's my notes. We're doing these in general. All right, so looking at this line, what do I want to shade above or below the y-intercept? I want to shade below the y. So here's my y-intercept. So I'm shading on this side of the line. Okay. So that whole side of the line. I just use the y-intercept to tell me above or below, but my line is what cuts the graph. Okay, so now let me look to see where it would overlap. So I need to be inside the circle, but below that line. So that's right in here. So that is the solution to this system. So with inequalities, you're not getting a specific point. You're getting a region. Because that says that anything inside here, this shaded region, will work for both inequalities. Pick a test point. So pick 0, 0. So 0, 0 is inside that shaded region. Okay, 0 plus 0, that's less than or equal to 25. 0 plus 0 is less than or equal to 5. Okay, so any point in that shaded region will make those true. Questions about that? Okay, let's do another one. So I'll let you get started. So this first one is a circle. What's my center? And my radius? 4. So, will this be a solid or dashed circle? Solid. Okay. And will I shade outside or inside? Inside. Okay. So my second inequality is a line. So I'll get y by itself. So you should have y is greater than negative 1/2 x plus 5. So start at 5. And then down 1, right 2. Again. Up 1, left 2. Will this line be solid or dashed? Dashed. Okay. Right, will you shade above or below? Above. So here's your y-intercept, so I'm shading on this side of the line. Okay. So where does it overlap? It doesn't, right? My circle shouldn't go up at all anyway, where it is, like that should be the highest point here at 5. So this does not overlap anywhere, so it's no solution. That means no matter what you plug in for x and y, it won't be true for both. It can be true for one, but not the other. Okay, questions about that? Okay. All right, we're going to look at just one word problem here. Okay, so in general, if you're going to break even, that means that the money you make should equal the cost to make that thing. Okay? So your revenue, which is the money you make, equals your cost. So that idea is not just for nonlinear systems. That's really for anything you want to do about breaking even. Your revenue and your cost should be equal. So applying that to some nonlinear equations, there I have this problem here. Okay, so if it says to use a break-even analysis, that's to say your revenue should equal your cost. Well, it gives me equations for both r of x and c of x, so let's just plug those in. So I'm going to plug this in for r of x. So negative 0.1 x squared plus 1.8 x minus 2 equals. Then I'll plug this in for c of x. So 0.1 x squared minus 1.2 x plus 7. quadratic. I see a quadratic, so how do I solve? What should I do? Yep. Move everything so it's one side's equal to 0. I'm going to move from the left to the right, so I have a positive x squared. Okay, so I'm going to do this all at once, but just be careful when you do this. Maybe show the work. So I'm going to add 0.1 x squared. Okay. I will subtract 1.8x. Make sure it's all lined up, and then I will add 2. Okay. So I get a 0 on the left. 0.1 plus 0.1. 0.2. Negative 1.2 minus 1.8 is negative 3. And 7 plus 2 is 9. Since I have a decimal for a, I'm just going to go right to quadratic formula. Okay, so what is opposite of b? Okay, and then negative 3 squared minus 4, what's a? 0.2, and what's c? 9. Okay, all over 2a. Okay, so let's check the discriminant. So what's under the radical first? Make sure it's positive, so we make sure there is a solution. Uh, 1.8. Okay, and then 0.4. So this is irrational, so we're going to have to round. So we'll do this in 2 steps. We'll do 3 plus square root of 1.8 divided by 0.4, and 3 minus square root of 1.8 divided by 0.4. After you do the adding or subtracting, you have to hit enter or equal first, and then divide by the 0.4. Let's think about where to round them. So this says copies, let's see, that's 100,000 copies. 100,000. So how many zeros are in 100,000? 5. So when I write my answer, I'm going to write, it's like saying 5 zeros after that. So I'm going to move my decimal place 5 places. So let's round to 5 decimal places. Okay. So don't move the decimal yet. Let's just talk about when we add these. So 3 plus square root of 1.8. I hit enter, divided by 0.4, and I got 10.85410. Okay, 5 places. Is that what everybody else got? So now let's do the same thing, but we want to subtract. So then I got 4.1458, and then I see it's a 9/8, so actually this is going to be 90. Okay, so now to just write it in hundreds of thousands, you just moved your decimal place all the way to the right, so 1085410. That tells me that it's 1,085,410. And then 414590, 414,519. Or 90, sorry, not 19 copies. So don't get too hung up on the rounding like I was talking about with the hundreds of thousands. The most important part is that you could solve and get solutions here. Yeah. If you just wrote this, you would miss a point because that's not. But if you wrote this and it said 10.8, whatever, 100,000, I would take that.